Now we start on chapter 6, and this chapter is about work and energy. Now, in previous lectures, we looked at the motion of objects. First, in a kinematic view, where we just looked at the motion, and then we looked at it in dynamic view, where we looked at the forces that cause this motion. We now take another look at dynamics, but instead of looking at the forces in particular, we're going to look at them in terms of work and energy. The most important thing about energy is that it's conserved. There's a lot of different kinds of energy. We have mechanical energy, chemical, electromagnetic, thermal, nuclear, all kinds of different energy. And energy can be changed from one form of energy to another form of energy. For example, your car uses gas, and gas holds its energy chemically, so we have a chemical. In your car, we change that chemical energy into motion or mechanical energy. Or that chemical energy is changed into electromagnetic energy to run your headlights. Or it's changed into thermal energy to run your heater. The total energy, though, stays the same, right? You can't get more energy out of that gas than what was in there before. Though, in the strictest sense, you have to include the air and the oxygen that your car uses to burn the fuel. So when we say that the energy is conserved, you have to think about all the places where the energy comes from. Okay, so why do we use work and energy when we have our dynamics that we just took a look at in Chapter 4? Well, one reason why is that both work and energy are scalars. Okay, remember that scalars have no direction. They only have a magnitude. Okay, now this is going to make it easier for us to work with work and energy because we don't have to deal with them as vectors, right? We can just use them as scalars. Okay? So we're first going to talk about work, because work provides a bridge between the force and the energy. Since we were talking previously about force, and we're going to also talk about energy, we'll talk about the work first.